Hi, my name is Rich Shandross. Can you hear me okay? Should I move the mic up? All right. I'm with Navigant Consulting, and this panel is the one on networking, really. Before I ask the rest of the panel to introduce themselves, I'll just set the table a little bit. We've got our devices, we've got our data, we've got our applications and so forth. We have to get the information, the data, from the field into the servers and the cloud and wherever else it's going to be. And so all these folks on the panel, they have opinions and products and ideas and services and so forth about that. I used to work at a military contractor, General Dynamics, and we used to do trade studies for everything. You know, you're trying to figure out what kind of technology you're going to use for some server or some communications device and so forth, and you do a trade study. So I think a lot of the focus of the questions we're going to ask right now are about what are the trade-offs, what are the dimensions that you have to think about, and you've got choices. You know, now that, as this whole conference is talking about, the future is here. So what are your choices? What are the pros and cons? How does somebody, if I'm a COO of a company that's producing an innovative auto engine part, and I need to improve my operations, where do I start? Which one of these network solutions do I think is going to be suitable for the kind of solution that I have, and what kind of solution do I have based on the networks that exist? So with that, I'll just let everybody else in the panel introduce themselves, and we'll get going.
Chris Walcutt with DirectDefense. I've spent about 20 years in the cyber and critical infrastructure security space for IoT connected devices and energy, water, wastewater, oil, gas, and mining. About 10 years of that has been in industry, and about 10 has been in consulting. So I'm going to be focused a lot around the risk issues, the third-party vendor risk for the system owners, the integration type issues that come up as we discuss the various products and solutions.
Hi, good morning. My name is Samir Trivedi. Little over 10 years I've been in energy space, either power quality, energy management, and then transition into the grid modernization or the smart grid of the world that we live in, and then into the smart city and connected of things. So currently I'm working with Trilliant as a director of business development, and we are focused on connected of things and how to drive that expansion of it and how to bring that solution that matches either the power distribution and then drive toward the smart city.
My name is Ian Pilling. I head strategic accounts for machineQ. We're a Comcast business focused on the enterprise and industrial Internet of Things. We've focused really on being an enabler of third-party IoT solutions, providing network as a service to our partners.
Hi, I'm Patrice McAree. I head up innovation for American Tower. Traditionally, American Tower has been agnostic when it comes to technology, and we have a very large portfolio around the world. We have 160,000 towers, 40,000 in the US, 15,000 rooftops. We have a wide variety of assets, but we're starting to learn now that there's a key role for us in the infrastructure of the future. We're servicing a number of key IoT players. Of course, we service the mobile network operators. So we see a great opportunity in the emerging technologies and how we can position our assets, our capabilities to develop the next generation services and solutions.
Geoff, Bruce-Payne. I'm Business Development Director for IoT Solutions for Inmarsat. I've been doing remote industrial IoT applications for probably a better part of 15 years in various roles. Inmarsat is a global satellite network operator, so we are an infrastructure provider that has operations around the world, and we deal with a lot of industries that have far-flung operations doing interesting things all around the world.
Great. Thanks, everybody. Okay, so I'm going to start it out with pretty much the same question that I posed at the beginning. Considering that you know the industrial space and the commercial space is not like the consumer space where they're going to buy a new set of, you know, they're going to restock everything with their new iPhone equivalent of IoT every year. Where do they put their hard-earned dollars? What networks, what are the pros and cons of the various kinds of networks, and which ones are going to be most future-proof? So I'll start at the far end with Geoff, I think, since you've got the biggest picture from the satellite there, I think.
Yeah, so as I said, we've been doing these kinds of applications in industrial use for, as you can imagine, industries that operate in the far-reaching places of the world, a lot of oil and gas, mining, and they've been doing these kinds of industrial automation type applications and evolving that from private networks like SCADA systems into now trying to derive more and more information and insights about how to do some of the things we just talked about in the keynote, which is improve their business processes, drive more efficiencies, and find new ways of doing business. So satellite's an interesting one. It's actually getting a bit more interesting these days. For quite a while, it was a staid playing space of a few players. There's a lot of new investment going into what we call new space companies now, launching rockets, small satellites, doing a lot of innovative things and with some creative ideas, and a lot of it focused on enabling a very broad-based IoT infrastructure in the far-flung places of the world. So for us, really, we're working with a lot of different technologies and a lot of different industries, and really our hallmarks and the things that customers look for from us are really reliable connectivity and secure connectivity. And a lot of what we end up doing is really right-sizing how to get that data back from the industrial appliances and people operating in the field into something that can use and process that data and then make decisions around it.
Yeah, I would just comment that if you look at the evolution of networks over the last 20 years, it's traditionally followed a linear path, but now it's probably one of the most exciting times in mobility and wireless. You have all the IoT players coming in with new technologies. You have the mobile network operators globally now starting to really focus on IoT. T-Mobile, for example, last year launched their NB-IoT network for $5 a year for low-power wide area network coverage. So I think the flexibility now in network selection, the hybrid networks that are evolving today, the locations of where these network assets are deployed is also very, very relevant. So there's tremendous choice on technology and capability. I mean, there's LoRa, there's Sigfox, there's a number of them. We carry almost all of them on our networks. But there's also a key component of that when you're designing a network is where you put these assets. Physical layer is, as Geoff mentioned earlier, is still very, very important. It shouldn't be a secondary consideration. It should actually be a primary consideration. We partner with a number of IoT players, and often that location of the network, the design of the network, is almost a secondary consideration to the technology. They, in fact, should be co-equal. You should be planning the network, looking where you can host assets and deploy your network extensively.
I guess I'd add maybe that the type of connectivity I think really depends on the use case that you're looking to enable. And we've elected to, as a starting point, to start with low-power wide area networking, and that's really geared towards use cases that require sending small amounts of data from either hard-to-reach places or from over long distances. And if you're going to deploy hundreds of thousands or millions of something in the wild, you need them to live in the wild on a battery for long periods of time. And in that case, something like power optimization is really critical. The other component that I'd add is that you also need to look at the sort of the density of the network. If I have this large fleets of assets, how close is the network to my device? That has implications for the power and reliability, throughput, et cetera.
Yeah, when we talk about network, is of course reliability, scalability, and secure. So three things are definitely important, and we need to focus on that, where to put the money there. But then also, how does it work from one dense area to less dense area, and how does the application suite enables that transition throughout where the network needs to be deployed, and how seamlessly all the devices are connected. And of course, the data that needs to be driven. We all know that data is the key, and there will be so much data driving. How we can drive that through with the quality of service that network needs to provide in a commercially effective manner. So that's where the network needs to be identified. That's what needs to be driven through and deployed through.
It's interesting, over the years, these networks have evolved. So, if you go back 20 years, a lot of them were just segmented, and there wasn't a lot other than the basic segmentation of the network. Now the system owners that are looking to deploy these various technologies are looking in a lot of cases to monetize them if they can. So if you look at a smart cities infrastructure, they want to know how they can monetize that investment beyond the initial use case, whether that's a city, whether that's a utility. And that's where a security services firm a lot of times, or if there's security in-house in the product companies, need to take a look at the whole footprint. Because once you invite third parties to participate in that ecosystem, you need to know whether they are a good bacteria or a bad bacteria in your ecosystem, and whether or not they're going to cause problems for you down the line. A lot of times the security controls are baked in the way they should be. You've got proper encryption, you've got the capability to do segmentation, but a lot of times the capability to monitor gets overlooked. And that's where you end with problems. If you can't monitor, you don't understand what your baseline is for that ecosystem to have a better understanding of when something starts to go wrong. So my challenge to the product vendors would be to make sure that you've engaged. Your product may be perfectly secure as a product off the shelf. As soon as you put it into the environment where it's going to live, it becomes an ecosystem and takes on a life of its own, and it needs to be assessed and addressed in that environment in that manner.
I love that point. And I'm curious to know what the panel thinks about the responsibility of the network in terms of keeping itself whole. Does the network need to impose minimum standards on the devices? What does the network do to keep itself whole? Thinking of the challenge that Chris just put forward. Anyone?
Well, clearly, if you're going to provide the network, and we do that as sort of a provider of managed connectivity, it's not just the security of the data in the packet being sent, but there needs to be some level of is the device that's connecting allowed to be on the network. And so the LoRaWAN is the flavor of low power wide area networking that we've chosen, and it serves that dual function of both encrypting the packet and also managing ensuring that the device is allowed to be there. But I think one of the gentlemen made the point. The other piece is if I'm, as an end customer, I'm going to rely on this to get my data securely from the device to my cloud, I need to know that there's somebody monitoring the network, as opposed to it just sort of maybe it'll appear in my cloud, and that's it. That's a key piece.
Yeah, there's a lot of layers to the security aspect, and there's certain aspects certainly that the network is going to be responsible for in terms of transport and on and off and who's allowed. But then there's a lot of other aspects you have to consider around the overall solution in terms of what the device that's attached to the network is doing, how it's maintaining its own security, or how some supervising entity is maintaining that on a broad basis. One of the things that is an interesting challenge for us, we talked about, and you've mentioned LoRa as a new technology, relatively new technology in the IoT space. We're looking at now working with enterprise customers who are deploying effectively private networks in these far-reaching places. And it becomes quite a challenge for them to go from their current business models to now the possibility of having becoming a network operator and owning a network infrastructure that might be used by someone else for other purposes. And I think that we're really at the early stages of some of those concepts, and it's going to need a lot of work to get through and understand what all the interplay is.
Yeah, I would just add that there's a couple things happening in terms of the virtualization of networks today. A lot of greenfield operators are starting to packetize and move to a sort of virtual core. So literally the network lives everywhere. You can do authentication, you can do validation at any data center locally. The carriers, the mobile operators, are also moving in that direction as well. So they're starting to move to having authentication just about everywhere where the network exists, as opposed to going to big centralized data centers. So that trend is really driving, I think, adding to security. LTE, for example, is now, the operators are confident enough they can run LTE in private, in open spectrum. They can run it in unlicensed spectrum. They're doing that now with CBRS and some of the new unlicensed spectrum. They're even doing it over Wi-Fi. So you can start to see there's a real virtualization of the network, but also the security is still migrating out through the cloud to all these unlicensed networks as well. So it's pretty exciting.
So for Trilliant, basically we already build in security. So we have unlicensed spectrum, but then we provide mostly to utilities to start with, which is optimized security requirements. So It is built to security to the level to end-to-end, from device level to the back office, to the back end. Device plays this connectivity role, and it has a physical security, but the network built on the privatization on unlicensed frequency, that offers the security aspects that we heard in the keynote that somebody's trying to hack into our grid system, that can be avoided. So that's not only the multi-purpose network and connectivity from deployment perspective, but also the scalable security and also interoperability. How do we play together so that security is transparent across when we have to play? Because there are some devices that are available right away and it's accessible. But then there are some devices on the geographic location that you can't even reach that. Now you have to partner with all of us and understand how do we just scale that across and become secure end-to-end, even with the interoperability comes into play.
Okay. I'm going to take a minute here and open it up to the audience. We don't know exactly what people want to know and need to know about networks, so let's take a couple questions for the panel. Yes?
A quick question. In the last session, there was a question about privacy and security. And I'm just wondering what your opinion is on centralized versus decentralized architecture and edge computing. Thank you.
Leave it open to anybody, really.
Yeah, I can comment on that. We're getting a lot of interest with our tower sites. You know, we have the real estate in the tower. We're getting a lot of interest from the cloud players and a number of other folks in that ecosystem going to the edge. And there's active efforts from some of the major cloud players to migrate some of their infrastructure to the edge. Of course, security has to be maintained and sustained. Some of the local compute, local processing, we think will eventually, in fact, in the near term, move to the edge. Stuff that doesn't have to go back to a centralized architecture. But of course, security has to move within, and the cloud folks are, we think, comfortable enough that they can move more and more of that centralized processing to the edge through little mini data centers, which are housed locally and secure, just as the big data centers are.
I would take privatized and edge computing in two different segments. When we look at the grid modernization and smart grids of the world, and utility plays a very definitive role into it. Security is already built into it, and the device level smartness is needed just so that the network is not overburdened by the tremendous amount of the data coming in. When the meter is reading every day 15 times, every 15 minutes, of course there are a lot of data is there, and that burdens the network. When you look at the smart city moving out of that grid, which is connecting power line to the smart city now, that becomes more important because now somebody's moving across the road and you don't want to take that image and ship it out. So that is a privatization, a private issue, because somebody might say, I'm not happy with that. So that needs to be converted into 1 and 0. So that is what the smartness is very important at that point, that what kind of data is being transported and who owns the data, then there is the next question. It becomes a little bit less, I would say, the controversial once we prove that if you're passing through the road and we just send 1 or 0, or just the outline of it, I cannot find out where you live and where you end up eventually, that becomes more palatable. I think the point I'm making is that that issue really enables the smart city movement that we need to. I think there is a lot of questions about what needs to happen in terms of the planning and the decision making. That is one of the aspects that can help tremendously in migration and adoption of the smart city technology.
And I see probably a threefold approach to this. So you've got the responsibility of the data processor or data owner to know what data is there and to be able to identify it in a meaningful way so that you can put the correct privacy and security controls around it. I think we're seeing a push for this in Europe right now. The GDPR privacy standard goes active at the end of May with enormous financial teeth around it. And there isn't really anything like that in this country right now, but I think people are concerned that we may go that route. So with that comes the need to understand truly where that data sits, how it's been tagged, and how it can be addressed. So then that puts onus on the product vendors to see to it that they have the mechanism or a capability to be able to treat that data differently, or even identify it if it's been tagged in a specific manner. And on the future of the processor and chip manufacturers to be able to provide the horsepower necessary to do that processing at the edge. So really, there's an evolutionary life cycle. As you get enough capability at the edge, then you can handle the technical piece of it. Now you've got the data privacy concern around whether or not you know and understand what that data is and what you're trying to do with it. And then that comes back to the system owner as it's integrated to be able to understand how it's all going to fit together and whether or not those controls have been implemented. You've got the horsepower, you've got the controls. Are they being implemented properly? And then lastly, you've got concerns around whether or not you have the capability to take action on those controls once they've been put in place.
Let's take another question. Anybody? Okay. You and then in the front row after that.
My question is like, there's a lot of networks that are secure that are actually being built in parallel. So in a lot of solutions we are discussing today, you need to take the data out of that network and push it to the cloud. The customer, the public sectors especially, they are looking into that kind of solution, but I think the biggest problem is like, what is the bridge that takes the data out of a private network to bring to the third-party provider? I think that's the holy grail where we interconnect systems. So my question is like, is there an emerging standard? What are the best practices for forming those bridges across secure networks?
I can start with this one if you want. Okay, sure. So right now, as I see it, and as a service provider only, I try to remain vendor agnostic, but I'll speak to the topic. Really, Microsoft has gone down that path. Amazon has gone down that path. There's a company called Clearblade that has gone down that path. And then there may be products from my colleagues here on the panel as well. But basically, that concept of the industrial bridge or the IoT bridge, there are some emerging players that are starting to make inroads into that space and try to be underlying technology agnostic while providing solutions. One of the considerations there, and as you move into the cloud with your data, if you've got multiple distributed smart cities networks or micro networks, however you want to look at them, is the co-tenancy capability to see just your data or just a specific client's data in the cloud and how you maintain that. So yeah, there have been some inroads in the technology, and I don't know whether or not my colleagues here on the panel have gone down that path or have contained themselves to the networks that they design and build.
Yeah, I think I would add to it that multi-tenancy is a must, because when the network is provided as a one aspect, and I've seen instances where utility can say, well, I want to deploy 100,000 meters, and then I want to extend to the lights so that I have the same infrastructure and I connect. But then, by the way, the lights aspects are probably owned by munis or co-op that they are my customer. But they cannot operate it because they're small. So I have to help them. So that security aspects, privacy and everything else, that scalability, quality of service, everything about it is transported to different level. But it's a multi-tenancy, so to still have the munis or co-ops, the city has access, but it's a secure way. But it's operated and owned by the utility. So there's really a mixed solution from the one system operating, so to speak. It's not fragmented. I think that evolution will come in when the citizens will interact and say, fix my pothole. I mean, that interaction when it goes in, that time probably the question will come up as, okay, hold on, now where that data is going, because now somebody other than all the security built in is entering into it, inputting the data. So that's a little bit out there where it's a thought process, and people are trying to understand that, how to implement it. But so far, I think from Trilliant perspective, it's all managed in one system.
Yeah, well, you sure stole my thunder, but
sorry.
But I think the tendency is to sort of assume that closed or proprietary network is inherently more secure, and there may be some advantages, but increasingly with global standards like LoRaWAN, you can have a multi-tenant network that does offer high level of security, and then doesn't force the owners of the data, the end users of the data, to be locked into your scenario of I've got a smart meter and then I want to layer on something else, and if the network that I chose was purpose built for my meter, it doesn't do me any good. So I think the onus is on, as long as the owner of the data has the, is the only one who has the keys to unlock the data, decrypt the data, then I think it solves for that challenge of having a sort of public, multi-tenant network while ensuring the security of the system.
Yeah, a couple of developments to look for over the next few years. In the next few years, you'll start to see 3.5 gigahertz, the CBRS network will start to be deployed extensively. This will offer private LTE-type networks virtually everywhere, in every in-building. We service a number of in-building customers, and in-building is a huge challenge for every type of IoT solution, simply because propagation is not ideal. So CBRS, which has both an open and a private aspect to it, you can run LTE over 3.5 gigahertz. That will offer some really interesting in-building type solutions for private networks, and they will be fully secure. They will essentially be cloud networks that will interconnect with the big network operators' networks as well. And you'll start to see a proliferation of those. The other thing is 5G, and we haven't mentioned 5G yet. 5G is just around the corner. The standard is nearly set. 5G from a security layer, from a latency perspective, has been optimized for IoT. So as 5G starts to roll out, you'll see it in dense urban areas first. It'll really bring massive bandwidth to network operators and to any service provider. It'll also bring this concept called network slicing, where you can essentially carve out layers of spectrum and offer them up to individual service providers within a core area. So really exciting. And then the third thing is it will have practically no latency at all. So it's really optimized for IoT, so you can run billions of devices on it. So I think those two developments, CBRS in the near term, 5G in the next 5 years, will radically reshape in the way in which networks are deployed, but also how they can optimize services for consumers and enterprises.
So is 5G going to take over everything, or are other networks going to be able to
Not at
compete?
all. I mean, that's our perspective is 4G has a long and healthy lifespan. The carriers, the biggest effort right now is densification. It is simply adding more capacity. You look at downtown Boston. Right now, I can assure you, right around us, there are probably hundreds of small cells interconnected with LoRa, with all sorts of other service provider elements. So 5G is really a lateral network in which much of the heavy lifting, the capacity, the latency services will run on. But 4G will continue to operate for years. What's really fascinating is you'll have lots of choices now. You'll have choices on uplink and downlink. You can create a hybrid network where you're using IoT to ask for a service. We're working with a number of TV broadcasters in which they're going to use narrowband IoT to actually trigger a command, but the downlink is using traditional over-the-air broadcast TV spectrum. So really interesting hybridization of networks, and you'll see that more and more with 4G and 5G. 5G is not going to be everywhere in 5 years, but it'll start to be in really urban areas where there's tremendous capacity constraints. So they'll coexist in many areas.
Yeah, it's great to hear that. Yeah, it will not take over, because that's what every time people think that's it, we're done. But it's a separate canopy. I see it because it's pure smart city play. Everything right now, a little over 60% electrical assets owned by utilities, one way or the other. So all the power system right now, what we know is owned by that. So utilities thinking, okay, what are we doing next, and who owns it, and how it owned. So that perspective is going to be there to manage, control, monitor, protect, and predict what way it goes in. But when the 5G comes in, that little bandwidth, that higher bandwidth, that just quick connectivity of autonomous vehicle and all the movements around it, it's a smart city, pure smart city application. Nothing to do with probably power quality, energy management, etc. It's purely just people counting and other aspect of the smart city, they're making the citizens' life better. So it's two separate canopy I see it evolving. Utility network's not going to go away. Munis, co-ops, and everything else is not going to go away, but they will be coexisting, and that's what my point was. Ultimately, we'll have to be together and understand that how we can scale, secure, and provide the quality of services every level across either the utility or the smart city in an effective way that can work better.
I have a thought on this. One of my alter egos is co-chair of the NERC-CIP Supply Chain Working Group. NERC-CIP is a Department of Energy. That organization is designed to help guide the future of what suppliers to the energy sector do in that space. But primarily those controls are focused around the transmission side of the grid, where the smart grid really is focused around the distribution side of it. So one of the challenges, I think, and one of the things that we've been discussing is how do we push the larger, more established players in the room to help provide resources and guidance around security for the smaller startups that have this new great IoT device that they'd like to convince a smart city to buy. My concern isn't necessarily about the misstep of the established partners. It is the adoption of, like IEC 62443 or something like that, that is going to provide a solid framework for somebody who's just starting out and saying, hey, I've got this great new idea. I'd like to put this thing on a smart cities network. Municipal governments, as the way their budgets run, tend to look for cheaper cost solutions. So if they can find something that's new, that's cheaper, that will do what they need, there's a risk there that thing designer, that widget designer, was great at designing the widget, but didn't have security resources or didn't have anyone looking over their shoulder or a platform to give them, to allow them to make it secure in the process. So I think that's really the challenge for the larger players, is to help push and provide resources for the ecosystem as a whole.
Quickly, I just wanted to come back to a comment that Patrice made, and I think you'd agree that I think a takeaway is probably that in IoT, a dense network is generally better than a less dense network. And your comment about 5G and providing that density, I think, was dead on. Ironically, that's sort of replicating the cable co model of having infrastructure very close to the whether that's the home or the business or the device in the field. And that's in sort of our next couple of years. That's what we'll be delivering, is a dense network leveraging cable co assets like customer premise equipment and things that hang from poles and head ends and all of that cable stuff. But each one of those represents an opportunity to integrate a gateway, a collector in there, and deliver that connectivity that's close to the endpoint. That's a great point.
Yeah, I certainly see there's really in the IoT space, there is no one size fits all. It really is application dependent on what value it's deriving or creating. So I think Geoff in the keynote mentioned something that's, people tend to think about what you're monitoring and managing, and that's a physical system. Well, actually the underlying communications to get that data from there to where you're going to use it is also a physical system. So you have a lot of interplay and challenges between what your physical constraints are. You're seeing now, communications engineers are having to become battery experts to know how things are going to behave, how long they're going to behave like that for. So it's quite a complex assembly. And there will always be a variety of technologies that's best suited to this job or that job, and what the information is you're trying to get and how you're going to use that.
Okay. Do I have time for one more question from the audience? Okay, yes. You had your hand up before.
Hi, so I have a question about actually going backwards from connectivity. So given the massive data breaches that we've had in the near past, both in scale and frequency, there's been a lot of talk about taking critical infrastructure, specifically in the industrial IoT and smart cities and so on, off the network and not providing connectivity. The argument being, if you can't hack into it, you can't destroy it. And so have you participated in those conversations? And it seems to be that there's a tension. I'd like to know where you stand on that.
Certainly, there's a balance there, and it's a business perspective balance, because what you gain by air gapping something, taking it off the network, is the hope of security. Certainly, the Stuxnet virus ended up in the Iranian centrifuge systems, even though it was air-gapped. So obviously, there are ways. But what you lose there is some modicum of resiliency and reliability. You lose distributed monitoring. You lose the capability to have real-time business process drawing data out of that equipment, whatever it is, and feeding back to some central point to allow for better business decisions, whether that's restoration of power, whether it's identification of a broken water gas pipe, whether it's network connectivity realization that's gone down, that there's a real challenge there. So the air gap, certainly it can help provide you some modicum of security, but at what cost? And is that cost acceptable in business? In my experience, generally it's not. They're willing to take some level of risk and put appropriate controls around it in order to be able to maintain that business process.
I think there's probably, I can't see a way to deliver on the promise of the IoT if it relies on private, wired networks. So it's clearly something that the industry, broadly is going to have to, address. I think there's probably one way to think of it though is there's probably a continuum of data, types of data, use cases where you go from the look, I just need to get a couple water reads a day, or is there a leak, or is there an alarm because my refrigerated unit is warm or cold, or whatever it is, and I don't know that has to be as secure as the centrifuge or whatever that was. But so I think there's probably one way to think of it.
In my experience, I've seen that isolation are critical assets. So from utility perspective, substations are highly secured, and that is where the central is, because the power is managed and distributed throughout the rest of the distribution grid system. So I've seen many times larger utilities are separating those network, and also restricting even the physical security as well. And most of the time it's on the fiber. So again, it's away from the IoT space. So that's the only way to really optimize maximum security, so that the rest of the distribution network is secure. But then when we go outside of that, then it becomes network security, and how secure the network is, that we all talked about it, and that's just built upon as a DNA of the network.
But I will say that in those distribution networks, a lot of times the utilities are doing distribution automation or recloser automation. So they're taking those smart grid networks that are originally designed for metering and adding on top of that the capability to operate those substations and the power pole, basically giant circuit breakers, if you want to think of it that way. One of the concerns there is that what is that introducing in the network? I personally have gone, at the request of a utility, out to a power pole, opened a box, and been able to get all the way back into the grid control center. Nobody really wants to talk about those types of issues, and certainly it's not something that's common, but it wasn't that they didn't have security controls in place, they did. It's that the security product that was chosen had a flaw and had not been tested. So to my point about you can take the best product off the shelf, it needs to be tested in the ecosystem to make sure that it's doing what you think it's doing. And we do my firm does a lot of security monitoring for companies around that space to try to figure out what is the baseline on your network so you can recognize those kinds of problems.
With that, I'm going to thank the panel. Thank you so much for a great conversation.